This is 8.3, solving by factoring with a GCF. GCF is greatest common factor. So the first thing we need to do is look for what these terms have in common. So our first problem, we have 10x squared and 8x. I know that 10x squared, 10 is an even number, so a 2 is going to go into 10 and a 2 goes into 8. But they also have an x in common. So I can factor out a 2x. So when I divide 10x squared by 2x, 10 divided by 2 is 5, x squared divided by x is x. And then we have plus 8x divided by 2x. So 8 divided by 2 is 4, x divided by x is 1, and 4 times 1 is 4. So that one is completely factored. So when we look at the next one, what do these have in common? Well, 28 is a multiple of 14, so I can factor out a 14. And then we have x cubed and x squared, so I can factor out x squared. So if I divide both terms by 14x squared, 14x cubed divided by 14x squared, there's one extra x in x cubed, so x is our remainder. And then we have negative 28 divided by 14 is negative 2. X squared divided by x squared is 1, so we don't have to write it. And we're finished. So on this one, we have 4x squared minus 81. Now I know that both of these numbers, 4 and 81, are perfect squares. So I can save myself a lot of time. So I know in order to multiply two numbers to make it a negative, one has to be positive and the other has to be negative. And then, because both of them are perfect squares, we can do the square root of 81 is 9. So I know positive 9 times negative 9 is going to equal 81. And the square root of 4 is 2x. Square root of 4x squared is 2x. Now, just to explain why this works, if we do the box thing just to double check, and we have 2x minus 9 times 2x plus 9, we end up with 4x squared. Negative 9 times 2x is negative 18x. 2x times 9 is positive 18x. And negative 9 times positive 9 is negative 81. So when we look at our like terms, this negative 18x and a positive 18x, they cancel out because negative 18 plus 18 is 0. And we're left with 4x squared minus 81. So if you recognize that they're perfect squares, you can save yourself a lot of time. However, one of the factors of C has to be positive and the other has to be negative in order for them to cancel out like our 18x's did. If they were both positive, you would end up with a b value. If they were both negative, you would end up with a b value. And we want our b value to add up to 0 because it's not present in your problem, in your original problem. So next we have this one. So I see 2x squared minus 22x plus 36. I immediately know that all of those values, all of those terms are even numbers. So I can factor out a 2. So when I do 2x squared divided by 2, I'm left with x squared. Negative 22x divided by 2 is negative 11x. And 36 divided by 2 is 18. So because I have a trinomial here, it is not completely factored. So this is where we go back to the idea from the 8.1 lesson. So you take your a, which is that implied 1, multiplied by c, which is 18. 1 times 18 is 18. So all the factors of 18, I'm looking for factors of 18 that add up to negative 11. So we've got, it's a positive 18, so that adds up to a negative. So both factors have to be negative. Negative 1, negative 18. That adds up to negative 19. Negative 2 times negative 9 is positive 18, and it adds up to negative 11. So there's our factors. So based on that, don't forget to bring down your 2. We have an a value of 1, so we can just set up our binomials. X minus 2, x minus 9, straight from your factors, 2 and 9. Negative 2, negative 9. So I'm going to leave those other 2 for you to use to practice. So look for what those numbers have in common. Oh, never mind. We're going to do number 5 because it's got a lot of x variables. So on this one, all of the numbers even, so we can factor out a 2. Then we have x to the 4th, x cubed, and x squared. So we can factor out an x squared. So we're left with 2x squared being factored out. So we have 2x to the 4th divided by 2x squared, which leaves us with x squared. 22 divided by 2 is 11. X cubed divided by x squared just leaves us with the 1x. And then 56 divided by 2 is 28. X squared divided by x is 1. So we are finished with our trinomial. So now we have to factor out our trinomial. So I know the implied a value is 1. C value is 28. So 1 times 28 equals 28. And the factors of 28 are 1 times 28, which adds up to 29. We can also do 2 times 14, which adds up to 16. We can do 4 times 7, which adds up to 11, and that's what we're after, is a b value of 11. So now we can set up our binomials. We can factor this. So we have our 2x squared on the outside. Because we have that implied value of 1 for a, we can just set up our binomials. So we have x plus 4, that's our first factor, and x plus 7, our second factor. So I'm going to leave the last one for you guys to do. So what is the main difference between factoring and solving? Factoring, you are simplifying. You are given an expression to simplify. And solving, you're isolating a variable. You're solving the equation. Isolating a variable. So when we do this next section says to solve by factoring. And it says watch your signs, and we also need to pay attention to greatest common factors. So the first thing I see here is a 3x cubed and a negative 3x. So I can factor a 3x out of this. So I have 3x times 3x cubed divided by 3x is x squared. And then I have negative 3x divided by 3x is negative 1 equals 0. So because I know that this implied one up front and this one on the end are perfect squares, and because it has a minus sign in the middle, I can factor this out. It's a perfect square binomial. So I have 3x on the outside. Square root of x squared is x. Now, to make a negative, we know we have to have a positive and a negative, and the square root of 1 is 1. So now, in order to solve this, we set all 3 pieces of this equation equal to 0. So we have 3x equals 0. We have x plus 1 equals 0. And we have x minus 1 equals 0. And this is how we isolate those variables. So if one part of this expression on the left half of your equation equals 0, the whole thing will equal 0 because you're multiplying 3x times x plus 1 times x minus 1. So if any of those pieces equals 0, you end up multiplying this entire expression by 0, which gives you an output value of 0. So now we have to solve each of these. So in order to solve this first one, I divide by 3 because it says 3 times x, and I'm left with x equals 0. That's one solution. And then in the next one, I have x plus 1. The opposite of plus 1 is minus 1. So I have x equals 0 minus 1 is negative 1. There's another solution. The last one, x minus 1. The opposite of minus 1 is add 1. So x equals 0 plus 1 is 1. So those are the three solutions for this function. So let's look at the next one. So the first thing you want to do is set it equal to 0. So in order to get that 48 to the left side, I have to subtract it. So this crosses out and leaves me with 0. So on the left side, I have 3x squared minus 48. They are not like terms, so you cannot combine them, equals 0. So I notice that these are both multiples of 3. 3 can go into both of those numbers. So when I factor out a 3, I'm left with x squared, and negative 48 divided by 3 is 16. So here we are with another perfect square binomial. So we have that implied 1 in the front, 1 times 1 is 1, and that 16 in the back, 4 times 4 is 16. So when we rewrite our binomials, we have 3, just the 1x. We're adding and subtracting because that's how you make that 16 into a negative, and the square root of 16 is 4. So now there's no x with the 3, so we don't have to worry about that. We are only setting the two binomials equal to 0. So you're solving for x each time. So that 3 on the outside does not have an x. We don't worry about it when solving. So in order to solve this first equation, x plus 4, opposite of plus 4 is minus 4. X equals 0 minus 4 is negative 4. The other one, x minus 4, the opposite of minus 4 is plus 4. So x equals 0 plus 4 is 4. Those are your solutions. So the next one. First thing you have to do, set it equal to 0. So I'm going to subtract the 54. I'm going to write a little smaller on this one because it's got more going on. So I'm going to subtract the 54 from both sides. Now again, 54 is not a like term with the 12x squared or the 63x. So you just line it up. So now look for your greatest common factor. So in this one, it's 3. So I'm going to divide that whole entire left side by 3, and I'm left with 4x squared plus 21x minus 27 equals 0. Excuse me, minus 18. Getting ahead of myself. So now you have to find the a times c thing. So we've got our a value is 4, our c value is negative 18. So when we do 4 times negative 18, we get negative 72. So we're looking up for the factors of negative 72, which we already know is going to be a positive and a negative, that add up to 21. And it's a positive 21. So because that 21 is positive, the bigger factor has to be positive. So we have negative 1 and 72, which adds up to 71. Ooh. We have -2 and 36, which adds up to 34. We can do -3 and 24, which adds up to 21. And there's our b value. So these are the factors we're going to use. So when we set this back up, because a is not 1, we need to list everything out. So we have 4x squared minus 3x coming straight from our factors plus 24x, again coming from your factors, and then minus 18. So all we did there was we broke down this 21 into -3x plus 24. They are equivalent. Everything else we just brought down. So now we can put that polynomial into your box. So we've got 4 sections of the box, 4 terms. So we have 4x squared, -3x, positive 24x, and -18. Now you can do this one of 2 ways. The first thing I notice is that there's negatives in both of those boxes. So I know there's going to be a negative up there. So how do I make a -3? And that would be 1 times 3. I know 3 doesn't go into 4x, so the 3 cannot be right there. Instead, the 3 has to be here. So to make a 3x, it's -3 times x. So then to make a 4x squared using an x, I have to multiply it by 4x. And then 4x times positive 6 gives you positive 24. And just to double check, -3 times positive 6 is -18. Remember to always go back and make sure your area model, your box thing, works every time. So now we have this 3 on the outside. We have to keep dragging along with us, but now we have our 2 binomials. So we have 4x minus 3 and x plus 6 equals 0. So because we're solving these, we haven't isolated x yet. We still have to do that step. So now that we've got it into 2 binomials and a factor in the front, we can set each of these equal to 0 and solve. So on the first one, we add 3 to both sides. We're left with 4x equals 3, and then divide by 4. And one of the solutions for this function is x equals 3 over 4. So then to do the other, it says x plus 6. The opposite of plus 6 is minus 6. So when we solve it, we get x equals 0 minus 6 is -6. There is your other solution. We're going to do one more from the back, and then I'm going to let you guys do some of these on your own. So the one I want us to do is the first one. Actually, yeah, let's do the first one. So the first thing I see is that both of them have a b, and both of them are a multiple of 5. So that's the first thing I'm going to pull out is that 5b. So 5b squared divided by 5b is b. 45b divided by 5b is 9. So at this point, all you have to do is break it down. So we've got 5b equals 0 and b plus 9 equals 0. Opposite of multiply by 5 is divide by 5. So we end up with b equals 0 divided by 5 is 0 as one of your solutions. And the other one, b plus 9 equals 0. Opposite of plus 9 is minus 9. So we're left with b equals 0 minus 9, -9. So I want you guys to use the next 2 as practice, and we're going to move on. So something really big to know is that when we solve for x, we call them 4 different things. So far, we've called them solutions. When we talked about 2 binomials being multiplied by each other in Unit 6, we called it intercept form. We wrote the intercept form of a quadratic equation, so these are also known as x-intercepts. Because the y value in all of your x-intercepts are zeros, we also call these zeros. And last but not least, they're also classified as roots, because sometimes you have to take the square root of your a and your c in order to create your 2 binomials. So your roots are also the same thing as solutions, x-intercepts, and zeros. So pay attention to this. All 4 words mean the same thing. So in this next section, we're taking what we've learned in the past and what we're currently learning, and we're sketching a graph. So if you know your x-intercepts and your vertex, you should be able to graph all kinds of parabolas. So on this one, a is 1, c is negative 12. 1 times negative 12 is negative 12. So we're looking for the factors of negative 12, and because it's negative, one has to be positive, the other has to be negative. That adds up to negative 4. In order for a positive and a negative to have a sum that's negative, the larger factor has to be negative. So if I do 1 times negative 12, I have a sum of negative 11. 2 times negative 6 has a sum of negative 4. There's your factors. And again, whenever x is 1, you just have to bring down your binomials, x minus 6. So to find our roots, our x-intercepts, our solutions, our zeros, we set each of these binomials equal to 0. So we have x plus 2 equals 0 and x minus 6 equals 0. Subtract 2, x equals negative 2, add 6, x equals 6. So when we come down to our graph, we now have our x-intercepts, our zeros, our roots. So one of them is at negative 2, and the other is at positive 6. So to find your vertex, we have negative b, so the x value of your vertex is found by negative b over 2a. So your b value is negative 4, so we have negative 4 over 2. Your a value is 1. So a negative times a negative makes a positive 4. 2 times 1 is 2. 4 divided by 2 is 2. So then you take that and you plug it right back into your trinomial to solve for your y value. And we're left with a y value of negative 16. So your vertex for this graph is 2, negative 16, which we can't plot on this graph unless you extended your page way down like I did, but I do want to show you guys the graph regardless. So 2, negative 16 is going to be somewhere down there. So when you draw your parabola, it's approximately like that. So the next one, we have an a value of 2, a c value of negative 4. 2 times negative 4 is negative 8. The factors of negative 8 have to add up to a positive 7. So because a negative and a positive have a negative product, we know that's going to be the case for our factors. The b value is positive, so our larger factor has to be positive. So if I try negative 1 and positive 8, they have a sum of positive 7. There's my factors. So remember, we have to do 2x squared, use your factors, negative 1x positive 8x, and your c value, negative 4. So now we can throw it into the area model, the box thing. So we have 2x squared minus 1x plus 8x minus 4. Now I know the only way to make 2x squared is to multiply 2x times 1x. And because there's an 8x down here, I'm going to put my 2x here and my 1x here. So to turn a 2x into an 8x, we multiply by 4. To turn a positive 4 into a negative 4, I multiply by negative 1. And just to make sure it works, negative 1 times x gives you that negative 1x. So now I have my two binomials. I know I break down this polynomial to 2x minus 1 and x plus 4. So again, at this point, you have to find your zeros, your x-intercepts, your roots by setting each binomial equal to 0. Add 1. 2x equals 1. Divide by 2. So one of your roots, one of your solutions, your zeros, is at half. The other one, subtract 4. And x equals negative 4. So there's your other. So when we plot this, we have x equals half right there. It also equals 4, negative 4, sorry, right there. And to find your vertex, still do that negative b over 2a thing. So we have your x value is negative b is 7 over 2, a is 2. So this one ends up with negative 7 over 4, which is negative 1.75. And when you plug that back in, you get your y value of 10.125. So again, this is another number that is not on our graph, but if it were to be on our graph, it would be to the left negative 1.75 and up to 10 and some change, and our parabola would look like that. So the last page is all about finding a greatest common factor. So when we look at this, what do they have in common? 12 and 32 are both multiples of 4. So I'm going to pull the 4 out of that. Then I have an x squared and an x. So I can take out one of the x's. And then I have a y squared and a y cubed. So y squared is what I'm going to take out. So I'm left with 4xy squared on the outside. 12 divided by 4 is 3. X squared divided by x is x. Y squared divided by y squared is 1, so we don't have to write it. Then we have 32 divided by 4 is 8. X divided by x is 1, so we don't have to write it. And y cubed divided by y squared is y. The next one, we have 18x to the 6th, 12x cubed. So 18 and 12 are both multiples of 6. And then we have x cubed. The 3 is your smaller exponent, so we're going to pull that out of it. So now we have 6x cubed on the outside. 18 divided by 6 is 3. X to the 6th divided by x cubed is x to the 3. And then we have 12 divided by 6 is 2. X cubed divided by x cubed is 1. And you're done. The last one I want to do with you guys is this one. We are factoring out a negative 1 here. That's the only thing that I can see that we can factor out from the trinomial. So we have negative 1 x squared minus 5x plus 6. Now you can factor that trinomial into two binomials. So a is 1, c is 6. 1 times 6 is 6. The factors of 6 that add up to -5 are -2 and -3. So I have a negative on the outside, which you don't have to write the 1, just a negative on the outside. X minus 2, x minus 3.